Good afternoon there, Wildcats. Welcome to your geometry class. In today's lesson, we will be discussing about proportions in triangle. So these are our objective in this video. First is we have to use the slide splitter theorem and the triangle mid-segment theorem to find the length of sides and segments of triangles. Second is we have to use the triangle angle bisector theorem to find the length of sides and segments of triangle. Essential understanding: a segment parallel to one side of a triangle divides the triangle into two similar triangles. If that segment connects the midpoint of two sides, the smaller triangle is in proportion with a ratio of 1:2 with the larger triangle. A segment that bisects an angle of a triangle divides the opposite side of the triangle into segments that are proportional to the adjacent side. We're going to review also these two vocabularies that we already discussed before. First is your corresponding angles, and second is transversal. Now let's proceed with our first example. And before we proceed with our first example, the essential question here is when parallel lines intersect two transversals, what are the relationships among the length of the segment formed? So in example 1, we are going to explore proportions from parallel lines. Example 1. In triangle JLN, if LN is 9.6, what are the measurement of LM and MN? Are the sides divided proportionally? You have to explain. Okay, let's start with this. Step 1, we are going to determine, okay? We are going to determine the, I'll just adjust my seat here. We're going to determine how triangle JLN and KLM are related. So JLN, so it's this one, JLN compared to triangle KLM. KLM, it's the big triangle and the small triangle. So the triangle share angle L. So they have they share angle L, meaning it's congruent now. Therefore, you have also your angle LJN. LJN is congruent to LKM. LKM. Okay. How are these two angles congruent? It's because they are corresponding angle. So we'll be using corresponding angle theorem. Therefore, if the angle here, so angle L, because they are sharing the same angle, and this angle here is congruent with this one, we can now say that these two triangles, your triangle JLN is similar to triangle KLM. Triangle KLM. What will be our reason? It's your angle similarity. Step 2, we are going to write a proportion. So write a proportion to relate the corresponding sides. So we can see here, I'll just change color of my ink here. We can see here is we have LK corresponds to LJ. So this one, LK corresponds to LJ. Okay, that is equal to, because we need the proportion here, LM. Okay, this LM here corresponds to the bigger side, LN. Okay, and then step 3, we have to use the proportion to find LM and MN. So you just plug in. So what's the measurement of LK? LK is 3 over KJ or LJ, which is 8, because 5 times 3, that's 8, is equal to LM over what would be the measurement of LN. This one, LN. Okay, the measurement of LN, it's given, it's 9.6. Okay, and then we do cross multiplication here. So we just cross multiply, you cross multiply. Okay, so we cross multiply that, it will give us LM. Okay, the measurement of LM is equal now to 3.6. So this is the measurement of LM. It's 3.6. Okay, guys. Because LK is equivalent to 3, we just plug it in. That's why we come up with LM when we cross multiply that. So step 4, we are going to find the ratio between the segment of each side divided by KM. I'll just change color again here. Okay, so I have LK. LK corresponds to KJ, which is equivalent to 3 over 5. Okay, or that is equivalent to 0.6. So, and you also have your LM. Before I forget, the measurement of, LM corresponds to MN. That is equivalent to 3.6 over 6. That is also 0.6. So since LK over KJ and LM over MN divides LJ and LN proportionally, okay, so we can now have your answer. Your measurement of LM is 3.6. How about your MN? Okay, your MN would be, it's 6. So the question there, because we only have LM, so the question there is MN, your MN is equal to LN, okay, because this one is 3.6 already. And we know that the measurement of LN is, we all know that the measurement of this one, it's 9.6. So 9.6 minus 3.6, this will be 6. That's why we have 6 here. Okay, so that's the measurement of, I'll just put there LM and then LN, or MN, sorry. MN is equal now to 6 units. Okay, now, on the next slide, we'll be looking at Theorem 7-5, which is your slide splitter theorem. So in here, you will see if a line is parallel to one of the sides of a triangle, then and intersect the other 2 sides, then it divides those sides proportionally. Okay, so if we have the segment MN is parallel to segment AC, MN is parallel to AC, then AM corresponds to MB. Okay, so AM over MB is equivalent to CN over NB. So we're going to use this splitter theorem on our next example. Use the splitter theorem to solve this. What is the value of x in triangle PQR using your splitter theorem? So consider other strategies you can use. Can you use proportion of similar triangle? So we'll see on that. So since ST, so your and to t here is parallel to PR. So your PS, so PS over SQ is equal to RT over TQ. Why? By side splitter theorem, we can write the proportion in terms of x and solve. So we all know that SQ is 4 plus 12. Okay, SQ, S to Q is 4 plus 12. Okay, and also TQ is 3 plus 9. TQ is 3 plus 9. So I'm going to put there, what's the measurement of PS? It's x plus 2. X plus 2 over 16 is your SQ. SQ is 16 is equal to RT. RT is x. It's here. And then we also have your TQ. From T to Q is 9 plus 3 is 12. And then we do the same. We cross multiply. So that when we cross multiply this one, we have it looks like this. 12 times 2, x plus 2, that's 12 times x plus 2 is equal to 16x. Okay, so you just go over with this is 12x plus 24 is equal to 16x. So I'm going to rewrite that so we can solve. So I have 12x plus 24 is equal to 16x. Subtract 12 both sides. 12x, sorry. Of course, this will be canceled. So I have 24 is equal to 4x. So divide this one by 4. Therefore, the value of x here is equal to 6. I'll just pass that for my final answer. All right. Next is we'll see our corollary of the side splitter. So if three parallel lines intersect two transversal, then the segment intercepted on the transversal are proportional. Okay. Now we'll be using this this concept on our application in the next example. So a reflecting pool is separated by walkways parallel to Lincoln Street and Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X feet represent? So we are going to take a look at the first is you look at the image that you have there. Formulate the problem. So first is the Walnut Street and Spruce Street are transversal of Jefferson Street and Lincoln Street. And the walkways are separated, the pool. It's in here. So Spruce, Jefferson, Walnut, and then Lincoln Street. Okay, so write an equation with x. So I'm going to write x over 60 is equal to 24 over 72. So because this is your x here, and then over 60. Okay, and then we also have 24 over 72. Okay, now once we formulate that, we cross multiply them. So you have 72x is equal to 24 times 60. So I have 72 here. So 72 x is equal to 1440. I'm going to divide both sides by 72. So I have x is equal to 20. I'll just box that. X is equal to 20 feet. So I'll just put there 20 feet. So when we apply the corollary to the side splitter theorem, so we can now say that the amount of tiling represented by x feet is 20 feet. Okay, this is what the amount in feet. Okay, now we are going to investigate proportionality with angle bisector for our example number 4. So we are going to see how this proportionality with in connection with the angle bisector. In triangle KLM, segment LN bisect angle KLM. When we say bisect, it divides the angle into two congruent part. So compare the ratio of Kn over Mn and KL over ML. Is triangle LKN similar to triangle LMN? We're going to explain that. So compute the ratio of the corresponding sides. So we're going to compute the ratio of the corresponding sides for the given measure. So what are the corresponding sides? Let's check. So we have Kn over Mn. So we're basing it Kn over Mn. Okay. That is the measurement of Kn is 10.5. So 10.5 over the measurement of Mn is 7.5, which if I'm going to simplify this one into decimal, that's 1.4. Now, we also have, let's check if KL will also give us 1.4. So KL over ML, which is KL is 14. And then, ML is 10, which is definitely 1.4. So it's 1.4. So the ratio, okay, the ratio of Kn over Mn and the ratio of KL over ML, okay, are equal. So I'll just put there, are equal. However, the third pair, NL and NL, the ratio is 1. So take note, NL over NL, because they have this two triangle, okay, when they when NL cut this one triangle to become two triangle, they share a common side, which is your NL, which is the ratio is 1. So the two triangles are not similar. So there's only two sides that are similar. So you can say now that the two triangles are not similar. Okay. So that is all about your similarity in proportion in triangle. So just to give you a summary, your theorem 7-5, which is the side splitter theorem. We also have theorem 7-6, your triangle mid-segment theorem. And we also have your theorem 7-7, which is the triangle angle bisector theorem. So thank you guys for coming and watching this video. And yeah, if you need help, just let me know. Join us on our live Zoom meeting. Thank you guys, and we'll see you in the live Zoom meeting. Bye-bye.